Yes, sir.
Yes, sir.
See, thoda sa we'll do another subtopic related to moles. And this one is how to do redox questions related to moles. Sometimes what will happen is they'll mix it up with redox. So I'm not going to teach you redox like the whole chapter at the moment, but just very basic. Does anyone know what redox is? What are the two things that happen in this?
Oxidation and reduction.
Which means gain of electrons. That's reduction. And so there's gain of electrons and there is loss of electrons. जो कि oxidation, that's your loss of electrons. Now in redox questions or equations, just remember right now very briefly, we just want to solve moles questions. Remember this: if somebody is going to lose, let's say there's X and there is Y, and they're reacting together. So if X is going to lose 2 electrons, so kya charge hoga? What is the charge on X then if it loses 2 electrons in this reaction?
Positive.
Or plus 2, right? So it's going to become X with a plus 2 charge. And similarly, if Y is to gain 1 electron, so Y will have minus 1 charge. So right now Y is gaining how many electrons it's gaining? I said it gains 1 electron. What's wrong with this equation? Is it a complete equation or is there something wrong with this equation? If I write down X plus Y equals X plus 2 plus Y minus 1.
Sir, and the other electron isn't gained by the Y.
The problem is that it's losing 2 electrons, but this is only gaining 1 electron, right? So if I have 2 Ys and each one of them gains 1 electron, अब मसला solve हो गया, it's the total electrons lost, that's 2, the total electrons gained, that's also 2. Is this clear?
Yes, sir.
So the point is, in a redox reaction, in a balanced redox reaction, the number of electrons gained and lost, they have to be equal at all costs. So number of electrons gained must be equal to the number of electrons that are. They must be equal to the number of electrons that are lost. So your last pointer, that's important. And I'm going to underline this. So for example, if I have another equation, I've got I'm just going to keep things simple at the moment. So I've got sodium and it's reacting with aluminium, C plus, and aluminium becomes gets reduced and becomes aluminium. Sodium gets oxidized. Sodium becomes +1 and aluminium gets reduced back to aluminium. As how would I balance this equation? Is it balanced or is it not balanced?
It's not balanced.
Okay, why? Because sodium is losing how many electrons? It's losing 1 electron, right? And aluminium gains how many electrons? It gains a total of 3 electrons, right? So अब करना ये कि किसको who's going to be multiplied by what number? Because I need to make the electrons gain and loss equal.
Sodium with 3.
Okay, so what we're going to do is we're going to multiply sodium with. I said we're going to multiply sodium with 3. That will that will make it a balanced equation. Okay? So make sure in a redox equation, it's not only that the number of atoms must be equal on both sides. What is also important is the number of electrons that are gained and that are lost. They must be equal as well. Okay, ये simple concept है. The electrons gained and the electrons lost, they have to be equal at all times, and that's how you balance the redox equation. Now we're going to link this up with moles. Okay, because remember, this is a different type of balancing. We're not going to focus on this right now, but it's a different kind of balancing where the electrons gained and lost. Keep this in mind. Redox equations, electrons gained and lost, they have to be equal at all times. अच्छा तो यहाँ पे ना this one. So we're gonna try this question now. This is page. Just hold on a second. So this one is page 34 of the same worksheet. So starting with the first question, okay, it's the question states. So there's just 4 questions, 4 questions on this. So the question states that there is a metallic salt, and it reacted exactly with 25 cm cube of sodium sulfite. So the equation for sodium sulfite is given. Sulfite is this thing, and sulfite is losing how many electrons? It loses 2 electrons, right? I mean, the equation, it loses 2 electrons. One sulfite loses 2 electrons. That's the ratio. Okay, that's इसको half equation कहते हैं, where they just talk about one species losing electrons. Like this one, Na loses 1 electron. That's the half equation. Al gains 3 electrons. That's the other equation. So that's the oxidation half equation. That's your reduction half equation. Now coming back to this, we figured out that sulfite over here loses 2 electrons. How many moles of sulfite do we have? कितने moles है ये? Calculator पे कितना 2.5
into 10 power negative 3.
So this one is 2.5 times 10 to the power negative 3 moles, right? So it's 1:2. So 1 sulfite loses 2 electrons. So 2.5 times 10 power minus 3 moles of sulfite will lose how many electrons? That's going to be double that amount, right? It's going to be 5 times 10 power minus 3 moles of electrons that will be lost. You clear? Is this clear?
Yes, sir. Yes, sir.
So this is about who loses electrons. Now, who's going to gain electrons? It's the other one that's going to gain electrons. Who's the other one? Ek to sodium sulfide. And the other one, what's the other one? That's the metallic salt. So the metallic salt, if this is going to lose electrons, the metallic salt is the one that's going to gain electrons, right? I just don't know how many electrons it's going to gain. I just say metallic salt, he's given you the oxidation number of the metal in that salt, +3. So let's call it +3. I know that this is losing electrons, so this must be the one that would be gaining electrons. And it has a charge of +3, but I don't know how many electrons it's going to gain. And I don't know what the final charge on the metallic salt, because I don't know how many electrons it's going to gain, so I don't know what the final charge is going to be as well. I said, can I figure out the moles of the metallic salt? Either volume and concentration. So how many moles do I have? 15.1 divided by 1000. What do you get?
Five into 10 power negative 3.
So we're getting 5 into 10 power minus 3 moles, right? So how many electrons should it gain? It should gain the same amount of electrons. If this is producing this much electrons, 5 times 10 power minus 3 moles, then this must be gaining the same amount of electrons. Because we did say that reaction ka rule hai कि the number of electrons lost and gained, they've got to be equal. Is that clear?
Yes.
So what's the ratio? 5 times 10 power minus 3 ratio 5 times 10 power. So that means 1m gains how many electrons? 1 electron, right? So what's the whole number ratio? It's 1:1. That means 1m plus 3 would gain exactly. So I now know what the question mark is. I know that it's 1. 1m gains exactly 1 electron. And the final charge would now be +2. Because if m plus 3 gains 1 electron, it's going to be +2. And +2 is going to be my answer. So I'm going to do this again. That it's we figured out that it produces these many electrons, loses these many electrons. So I tried to figure out who's gaining electrons, and they told us that the metallic salt is +3, and it's 5 times 10 power minus 3 moles. And these are the electrons that are produced. So we figured out that the ratio between them would be 1:1, and we were able to make a whole number equation with whole number ratios, and we were able to figure out what the final charge is. Okay, clear?
Sir.
Yes.
So 5 into 10 power negative 3 moles are like 2 electrons. So why are we using 1 electron?
Why is it 2 electrons? I mean, we don't. There was a question mark. We don't know how many electrons it is. वो तो ratio है equation का.
No sir, ये जो ऊपर है ये वाला.
नहीं उसको छोड़ दो. उसने it has the first reaction has produced these many electrons, right? And remember, I told you previously, don't compare the ratio of this with this. That 2 electrons is a ratio with sulfide ions. It's not with this one. Is that clear? This equation has nothing to do with this ratio. But that's this ratio. This 2 means if you had 1 sulfide, it's going to produce 2 electrons. If you had 2.5 times 10 power minus 3 moles of sulfide, it's going to produce these many electrons. What we know is these electrons were produced, right? So that's the same amount of electrons that's going to be gained over here. I don't know what the ratio is. I just know that these electrons were produced, right? So these are the same amount of electrons that are going to be gained by this. Iske moles kitne, iske moles kitne. That means that they're basically 1:1. Is that clear?
Yes, sir.
So just remember this, that don't compare the ratio of one equation with the ratio of the other equation, because that ratio makes no sense with this one. Okay?
Okay, sir.
So we're going to do a similar question, another one. So let's do this one. Now over here he's saying it's a very similar question. Over here he's saying that there's this thing, and it reacted with NH4VO3, and to oxidize it to Tl plus 3. So Tl plus 1 over here is getting oxidized to Tl plus 3. So I know that, so Tl plus 1, I'm just going to write NO3 anyways. It gets oxidized to Tl plus 3, right? So the whole number ratio is that it's going to lose 2 electrons. I mean, that's how plus 1 changes to plus 3, right? So in the equation with this is 2 electrons. How many moles do we have? 10 into 0.3 divided by 1000. What do you get? Moles
20 10 power 3.
So you're getting 3 times 10 power minus 3 moles, right?
No, sir, wait a second. Sir, I think I did it for this one. Let me just do it for this one.
We 1 3 times 10 power minus 3. Check, just double check this.
Yes, sir. 3 into 10 power negative 3.
So how many electrons will be produced? That's going to be 3 times 10 power, 6 times 10 power minus 3 moles, right?
Yes, sir.
So that's the amount of electrons lost. Now, who's going to gain electrons? NH4VO3. I mean, they're reacting with NH4VO3. So that means NH4VO3 is the one that's gaining electrons, and they're actually very specific that vanadium is the only element reduced in this reaction, right? So vanadium is the one that's gaining electrons. Now, I don't know how many electrons it's going to gain. I don't know what's going to happen to it at the end, right? But they've been very clear that vanadium is the only element that is reduced. That's the one that's gaining electrons. What's the charge on vanadium over here? NH4 is +1. So I'm going to try and figure out the charge. NH4 is +1. So VO3 must be -1. Do you know how to find out oxidation states? Although we're not doing this right now, but how do you find oxidation states? For V, we don't know what V is, so I'm going to take it as X. Oxygen is -2. and that's times 3. And the total charge on the entire thing is -1. If I solve for x, it's going to come out to be +5. DK, it's we add up the charges and that's equal to the total charge. So x comes out to be +5. That means V over here has a charge of +5. Is that clear?
Yes, sir.
So electrons produced kitne hue? That's 6 times 10 power minus 3. So that means 6 times 10 power minus 3 electrons must be gained. And how much vanadium do we have? We have the moles, that's 20 of 0.1. So that's, how many moles is this? That's
2 into 10 power.
So that's 2 times 10 power minus 3. So what's the ratio coming out to be? That's 1:3, right?
Yes, sir.
So that means the whole number ratio is that one vanadium, which is +5, would end up gaining 3 electrons. It's 1:3. So V plus 5 will change into, if it gains 3 electrons, it will change into V plus 2. So the final oxidation number of vanadium is going to be +2. Is that clear?
Yes, sir.
So that's going to be +2. And Ahmed, is this question clear?
Yes, sir.
So for the next one, we can do similar questions that so let's do this one. Now, hold on a second. So let's try and do this one. Lead 4 chloride will oxidize bromide ions to bromine. So they've told us that bromide ions turn to bromine. So bromide ions, they turn to bromine, right? And the lead 4 ions are reduced to lead 2. So Pb4 plus is reduced to Pb plus 2. So that's my equation. Pb4 plus goes to Pb2 plus. I can make 2 separate equations, or I can just combine it in one equation. So how many electrons are they're being gained, right? So that's 2 electrons being gained, right? And Br minus 1 goes to 0. So that means it loses 1 electron, right? So I need to double that. So it should be 2 Br minus 1s. Is that clear that the equation is now balanced? That the number of electrons lost and gained are equal? Is this clear?
Yes, sir.
So if that is clear, all I have to do now is I've got my equation now. So lead 4 K moles, I've been given 6.98 grams of lead 4 chloride, PbCl4. Can you figure out the moles? How many moles this would be? 6.980 grams divided by lead 4 chloride, that's PbCl4. That's I think 207 plus 35.5 times 4. So how many moles are we getting for lead 4 chloride?
Point 0.02.
So we're getting 0.02 moles. So if that is 0.02 moles, what mass of bromine would be produced? That's 0.02. So that's bromine would be 0.02 as well, right? It's going to be exactly 0.02. 1 second. Well, 1:1 and bromine, that's 0.02 moles. And he's asking for the mass. It's going to be multiplied by the mol of bromine, which I think is 80 plus 80, that's 160. So the mass would come out to be, what is the closest answer? I think it's going to be A. Okay, we're taking rounded values, like, so this is going to be
3.2. 3.2.
I just say 3.2. So C is the closest one, right? So it's going to be C.
Yep.
It's got the ratio, the electrons lost and gain are equal, right? That's 2 electrons gained, 1 electron lost, but then 2 bromides, so 2 electrons lost. So it's going to be 1 ratio. You want to clear? Is this clear? This one?
Yes.
I said, now the next one. SN2 plus ions, because remember, moles question, it's all about finding the ratio. The rest of the questions is the same. You find the moles of one thing, you find the moles of all the other thing. The rest is just calculating mass or doing other stuff. Now, this one. SN2 plus ions will reduce in MnO4 minus 1 to Mn2 plus. So we know that MnO4 minus 1 is getting reduced to Mn2 plus, right? So it's getting reduced to Mn2 plus, and the 10-2 plus are oxidized to 10-4 plus. So 10-2 plus are getting oxidized to 10-4 plus. Again, writing them together, right, in one equation. So how many electrons are lost? That's 2 electrons. And how many electrons do you think are gained? What's MnO4 minus 1? MnO4 minus 1. What is the oxidation state of Mn? That's X, and minus 2 times 4. And that's going to be equal to 8, right? Sorry, minus 1, the total charge. The total charge is minus 1. Individual charges must add up to be equal to the total charge. So that's X. And minus 2 times 4, that's going to be equal to the total charge is minus 1. X would come out to be plus 7. So that means Mn goes from plus 7 all the way down to plus 2. So that's a gain of how many electrons? That's a gain of 5 electrons, right? Is that clear?
Yes, sir.
Okay. Who's going to be multiplied by what number so that the electrons gained and lost are equal? We need to make the electrons gained and lost equal. How many Mn should, 5. Go.
Sir, Sn with Sir, Sn with 5 and MnO4 with 2.
Okay, so we're going to multiply Sn with 5. So if I have 5 Sns, the electrons would become 10, right? And Mn with 2, right? That's going to make it 10 electrons gained. So if I have 2 Mns, that would balance things out. So the ratio is what? It's 5:2. So we figured out our equation. So now he's saying that you got SnCl2. This is he's talking about Sn2 plus. How many moles is this? The MR is also given. So how many moles of Sn do we have? That's 9.5 divided by 190. So
0.05.
Sorry, 9.5. Get that 0.05? So I've got 0.05 moles of. So I've got 0.05 moles of Sn, and he's asking me to figure out the moles of Mn2 plus. How many moles of Mn2 plus do I have? So if I have 0.05 of this, ये 0.05 आया था यहाँ पे. So if I have 0.05 of this, so 5:2, so 0.05 to 0.02 होगा ना, that's right. Is that clear?
Yes, sir.
Yes.
So B is going to be my answer. Is this clear?
Yes.
Yes.
I just remember that. So you get questions like redox questions where you have to, when you make the equation, make sure you balance. We'll study the equation thing in a lot more detail later on. I just want to do a couple of questions. When you're doing ratios, especially these ones, the electrons that are lost. Over here, we didn't make an equation. What we just did was that this is losing these many electrons 6 times 10 power minus 3, right? So this must be gaining the same number of electrons. And by using moles and comparing them, I was able to figure out the equation ratio. That must be 1 with 3. Okay. You clear सारे questions? इनका बस देख लेना कि ठीक है, but is this clear all, Rafi?
Sir, not entirely. I'll do again in the videos. Sir, I'll do it again when you send me the video.
ठीक है, नहीं लेकिन इसमें कौन सा वाला नहीं कि
No, sir, वो भी मैंने देखा नहीं है.
अच्छा, इसमें what we can do is कि इतने detailed तो there are very few questions on questions like this, ठीक है? Just remember that in the redox equation, when you're trying to figure out ratios, the electrons gain and loss, they've got to be equal. इसका मैं बता देता हूँ फिर से एक दफा go through कर लेता हूँ कि if I have something that's losing electrons, then there must be some other thing which is the other reactant that must be the one that would be gaining electrons, right? So if this is losing these many electrons, the other one must be gaining the exact same amount of electrons. Or uske moles पहले दिए हुए थे, so we were able to figure out if they have the same moles, that means it's going to be 1:1. That one of this would be gaining one of this. So we were able to figure out the equation, the ratio. As a past member, you'll find very few actually questions on this. अच्छा, but go through these 4 questions once more, ठीक है? इसके मैं video lectures भी भेज दूँगा. The other one is that के एक मैं वैसे Google कर लेता हूँ कि moles latest. We are just solve here just a second. So ये फिर next day कर लेते हैं. I'll try and see if I can find more questions on this, but there are generally very few questions like similar to these. So now the other thing is we can also try and do we did commercial analysis. Now what we can do is we can start off with the longer questions, ठीक है, जो paper में आते हैं, and do a couple of them. So these ones, so let's start with this one. So now just remember it's a typical moles question, except that it's going to have many different steps. So this one. So let's start with this one. Okay, in order to determine its percentage purity, a sample of ammonium sulfate fertilizer. So this is the fertilizer over here. Okay, this one. And as I'll tell you the page, this is page 82. So this is what the fertilizer is. Okay, and now what he's saying is that a known amount of this fertilizer. Okay, remember we don't know. So we want to figure out the purity of this fertilizer. 5 gram sample of this fertilizer. So this is not actually 5 gram. It must be a lot less than 5 gram because it's impure. I said, so they've told us that there's a 5 gram sample of this fertilizer, right? I said it's reacted with an excess of NaOH, so it's reacting with NaOH. What is going to be produced? A salt, which is going to be Na2SO4. And what else? Well, water and ammonia, right? And if you balance it, it's probably going to be 2 NHTs, and it's going to be 2 water molecules. Is this clear? Well, apart the equation.
Yes.
So now what he's saying is that it's warmed with 50 cm cube of 2 mole per dm cube NaOH. Can you tell me how many moles this is? Because pehle wale ke moles, we can't find out the moles of this thing. It's 5 grams, but I don't know if it is actually 5 grams or not. So I'm not sure about this. For NaOH, I know how many moles of NaOH have I added over here?
0.1.
So we've added 0.1 moles. But remember, that's an excess. This can be masla. We don't know how much of it is actually reacting. So when all the ammonia had been driven off, the solution was cooled, and the remaining NaOH. So that means, remaining NaOH. So that means some of the NaOH is left over. Or isko yahan pe kar lete hain. So some of the NaOH, the remaining NaOH, what does it do with it? It is reacted with HCl. So the remaining NaOH, which we don't know how much of it remains, it's reacted with HCl. And what's the equation? It's going to be NaCl plus water. So I figured out the equation. Can I figure out the moles of HCl that are needed to react with the remaining NaOH? And that's the remaining. कितना HCl है?
0.0312.
So this one is 0.03.
12.
So it's 1:1. So how much of the NaOH is remaining? That's 0.0312 as well, right?
Yes, sir.
Okay. So you added 0.1 moles, and out of that 0.1 moles, 0.0312 is remaining. So how much of NaOH actually took part in the reaction over there? So you added 0.1, 0.0312, 312. As a 0.0312 still remains at the end, right?
Yes.
So okay, how much NaOH actually took part in the reaction over here?
0.0688.
This is a 0.088 moles. But stepwise, he's asking for the same thing, like calculate the moles of HCl, calculate the moles of 50 of the ones that you used over here. Okay. Calculate the amount in moles of NaOH that used up in the reaction with, so we figured that out as well, right? Now, last step is based on this, we are going to be able to figure out the moles of NH4 ammonium sulfate. Get ratio, that's 2:1. So how many moles? Divide this by 2, you'll find the moles of this. What do you get?
Can you repeat the question?
You figure out the moles of NaOH that took part in the reaction, right? So can you figure out the moles of ammonium sulfate? 2:1, so it's going to be half of that.
0.0344.
And this one is 0.0. And can you figure out the mass of this thing now? Okay, that's 0.0344. And that's going to be multiplied by the MR of this thing, which is, okay, 18 into 2, NH4 is 18, that's into 2, and so SO4 is 96, so 36.
I'm getting 4.54.
Is that a 4 point?
4.5408.
4.540, I'm going to write the whole thing, 4.5408 grams, right? So what's the percentage purity? That's the last thing he's going to ask you. So it was a 5-gram sample. That means the percentage purity of this thing would come out to be, if 5 may say,
90.816%.
so it's going to be 4.5408 and divided by 5 grams and into 100. Kitala 90 point?
816.
That's a 90.81. 6%. I said now again, now this one is a theory question, right? It's a structured question. Now over here, MCQ with the matter, like it doesn't really matter what significant figures you used in MCQs, but now it will matter, right? Because how would you present your, now every working has to be presented in the proper way. If you want to find the moles of HCl, tell them how are you going to find the moles of HCl. Make sure you write, don't answer it in this way. Make sure you write it down carefully with the correct significant figures. Tell them that it's concentration times volume. That's what you're trying to do. The concentration is 1. Like not just 1, it's 1.00 mole per dm cube multiplied by the volume, which is 31.2 cm cube that you're going to divide by 1000. And so if this is 3 significant figure, this is 3 significant figure, your answer, HCl se start kar lete hain. It should come out to be 3 significant figure, or it should be, when you're writing it down, it should be up till 3 significant figures. It should not exceed 3 significant figure accuracy. Every number over here is 3 significant figures that they gave us. This is 50.0, that's 3 significant figure. This is 5.00, that's 3 significant figures. So whenever you do your working as well, make sure it's clear enough. Okay, 50.0 over here, what you're going to do is the moles of NaOH, you can clearly show them what you're trying to do. Concentration times volume, and so it's going to be 2, but add the 0.00 as well into 50. Add the 0.0 as well, divide by 1000. And that does not give you 1, it actually gives you 1.00 moles. Clear? Is that part clear?
Yes, sir.
Yeah, how are you going to? Because remember, don't be careless with this. They're going to deduct marks for this. As a similarly NH4 SO4 from the moles of NOH, so everything. But you're going to write moles of NOH, which reacted. I mean, precise, clear statements reacted with. Just showing you this so that you follow this. I said that was the first. That was 0.06. That was 1.00 minus I think 0.0312, and that's how you got your 0.688. I think. Yep, 0.0688. अच्छा, so ये सारा तो हो गया. So your final answer, it should be accurate up till on your calculator, no rounding. What statement, what number should I write over here? I'm not going to write 90.816. It's going to be
90.8.
Okay, I'm going to round off till the third significant figure. That's going to make it 90.8.
We can also do one significant figure by seeing this.
Nee, it's 5.00 ना ये ऊपर देखो ना. वो तो मैंने गलत लिखा ना. मतलब I should have written it. I should have written as 5.00. And this in my working should have been written as 4.54. But not on my calculator. Remember, no rounding on the calculator. Your rounding leads to error. When you're writing or presenting the data, you're going to round it off. But even this value should be 90.816 on your calculator. It should not be rounded off. But when you're writing it, you're going to round it off. Okay, is that clear?
Yes.
So in but I remember questions similar to these. Make sure you just sketch it out. Okay, what's happening? Okay, what's going on? That would make things easier. If you try to attempt the question as it is without sketching or knowing or having a picture or a map of what's going on, then it becomes harder to solve questions like these. Okay. So, okay. Try these titration questions on page 82 then. Okay.
Okay, sir.
Okay. Take care. Allah Hafiz.
Allah Hafiz, sir.